Okay, it did tell me the video was too long before, so we may have to try these shorter. Um, it's okay. So far we have equation 1, equation 2. Equation 1 is just the definition. The only thing that can be the current velocity is the old velocity plus acceleration times time. That's the only thing that works in units. It's the only reasonable thing. Okay, everything's in meters per second. We're not allowed to have changing velocities, otherwise we would have some more terms in there. So in honors physics, it's just that. We'll call that equation number 1. It's the simplest one. Then we have some math facts. Displacement is average velocity times time. That's just distance equals speed times time. But now we know about directions. They're incredibly important. Okay, and then we have the average. To take the average of two things, you add them, you divide by 2. You know that. Okay, if we had changing accelerations, we would have a bunch more things we would have to average. We'd have to do a lot more work. But hooray, we don't. That comes later in calculus. Okay, and then we apply the same logic to equation 2. Delta x is x minus x0. Okay, so I need the average velocity. We showed you before how we plugged everything in, and we get equation 2. That actually covers everything but this one that I haven't read, equation 3. That covers everything on the equation sheet. You ready for a test yet? Not this week. We'll talk later this week uh, when we should do that. But then we have this one. We have v squared and v0 squared. Where on earth did I get that? And what good is that? Do you want to run screaming out of the room? Yes? Okay. Hopefully I can help. That's normal. Okay. First of all, it should kind of make sense because every single term is in meters squared over second squared. If I just square velocity or speed, I get meters squared over second squared. Acceleration times displacement is also meters squared over second squared. So it actually makes sense that I could add and subtract these things and set them equal to each other. The units work. In this equation 3, what is missing? Sure, Ryan. There's no time. Remember yesterday I kind of clumsily pointed out that we have to, so we don't have a choice. We have to solve this one problem for time first because otherwise we don't know the time. We can't plug into equation 2 helpfully. If we need to solve for both distance and time, one equation with two unknowns can't help us. But now there's no time. This equation tells what happens and you don't need the time. Ooh, that could be handy. How do you suppose I got rid of the time? Let's just play around with this. Let's call it delta x is v0t plus 1 half at squared. And then, let's take number 2. No, that's number 2. Number 1 says v equals v0 plus at, but this is honors physics. That's the same as v minus v0 over a. It's actually so much fun for me to teach Algebra 1 a little bit this year because they're like, oh, these properties, why? I don't know why they need to know the names of that stuff, honestly. I really don't. I don't know the names of that stuff. I have to learn it to teach it. But you need to know that it's okay to just flip everything around like that. If that equation, if this equation is true, so must be that one because I can make just pure logical steps and rearrange it. Okay? And you promised when you joined this class that you're that good at math. Okay. What happens if I just plug in those t's? We'll put a word or in there instead. Okay, we'll try to color code it. Let's see if this works better electronically. So then I have delta x equals v0, leave a big space, plus 1 half a, and then another big space. Okay, because there's v0 times v minus v0 over a, plus, that's fine, v minus v0 over a squared. Oh, you start to see it? Yes, no, maybe. Okay. Let's see that one. Okay, I'm going to keep this delta x. You know it's x minus x0. It says that on the equation sheet. Now I'm going to start to like distribute these. And I really kind of want to be clever about that. Okay, I'm going to watch my denominators pretty carefully. Distribute this v. We get v times v0. And then we get minus v0 squared in this first term. And I'm going to put it all over a. Okay. And then this one, I have a squared on the bottom. So I actually end up with 2a in the denominator. And then I have to FOIL. V squared minus 2 times v0 plus v0 squared. Not equals, excuse me. This should be a plus. Okay. Okay. All right. Fast math then. I'm free to just take this middle term and multiply by 1. Well, I should put parentheses. Okay. Why would I do that? Because I looked at the previous page and I know where I'm going. I should end up with 2a delta x. So then, saving math space, I take the whole side and multiply by 2a times 2a. Okay? And then, we should be able to just pick up the pieces. Well, let's do red. I have 2a times delta x on the left side. Oh my word. Okay. I have plus 2v times v0. And then I have minus 2v0s squared. I had to distribute my 2. Okay. I've got a plus v squared. Oh, we're going too long. And I have a minus, maybe I did that on purpose. We have minus 2v times v0. And we have a plus v0 squared. So those two cancel out. This one halfway cancels out. Let's write v squared minus v0 squared. Oh, look. So it's in a little bit different form. So I get 2a delta x equals v squared minus v0 squared. And you're good at math. You can rearrange that any way you want. So it's really the same two equations. I just substituted one into the other and simplified it. Okay. Any questions? Was that make some sort of gesture or look at me? If that was too much math gymnastics. A little bit. Calvin thinks so? Okay, I've got good news. On a test, you're not expected to reproduce that or derive that. Yes, sir. I want common denominators. So first I want to get a whole common denominator on the entire right side of the equation, and then I want to multiply both sides by that denominator. Okay. And I just judged it. I could have multiplied both this one top and bottom by 1/2 to get rid of the 2 to make common denominators, but then I have halves everywhere. Seems like more work. Okay. That's there's limitless ways really to do physics or math. I'm trying to do it the way that's the least work. So maybe you can help me find better ways, but that's the only reason I do it the way I do it is I think that's less work. Great question. Any others? Okay. Let's like cut my video here.